Then we'll talk about the energy in simple harmonic motion. So suppose you have this block connected to a spring and it is stretched. Okay, so you know it follows the Hooke's law. Hooke's law is what? Force acting on that block, or the spring force acting on the block, would be equal to what? Minus of kx, where x is the displacement, k is the spring constant, right? So then now this is the restoring force. Spring force is the restoring force. Suppose you want to move the block. Okay, you want to move the block from starting position in any direction. Then what do you need to do? As soon as you displace it, there would be a restoring force. So if you want to displace it further, you will need to do some work against what? The restoring force. That means the spring force. Okay, so the external force that you need to apply has to be equal and opposite, at least, to that of what? The spring force. So external force is equal to what? Kx. Okay, and therefore work done in small displacement would be equal to kx times dx. Okay, dx is the small displacement. Work done in the small displacement is this external force multiplied by dx, which is kx times dx, right? And now if you want to displace it from 0 to x, 0 to some position, okay, x, then what would be the work done? Just integrate this thing. Okay, so integration of kx dx from 0 to x, right? Integration of kx dx from 0 to x, k can be moved outside. Then integration of x dx is just x square divided by 2 within the proper limits. So lower limit is 0, upper limit is x. That means the limit is x only, right? So you need to substitute this x. So when you substitute that, you get the work done. Work done is equal to half of k into x square. Okay, so now in order to do this work, you supplied some external energy. Okay, you applied an external force. That means you supplied some energy. So that energy gets stored as the potential energy of the spring. Okay, so external force that you apply, it provides some energy. It gets stored as the potential energy of the spring, or you can say spring mass system, right? So this work done gets stored as the potential energy, and then it will also have some kinetic energy. What is the kinetic energy? Kinetic energy is half of m into v square, and you know that v is equal to plus minus of omega multiplied by square root of a square minus x square, right? So substitute that here, then you get the kinetic energy of the spring block system is what? Half of m omega square a square minus x square, right? Half m is there, then you put v square, which would be omega square multiplied by a square minus x square. So you put that and you get this kinetic energy. Okay, so m omega square can be written as k, right? Because we know that omega square is equal to k by m. So k is equal to m omega square. Okay, so therefore you can write the kinetic energy is equal to half k a square minus x square. So the potential energy is half of k into x square. The kinetic energy is half of k into a square minus x square, right? You add the two, then what do you get? So sum of potential energies and kinetic energies is half of k x square plus half k a square minus half k multiplied by x square, right? So that plus kx square minus kx square, okay, it gets cancelled out, and what remains is half of k into a square. So the total energy of an object performing simple harmonic motion is half of k multiplied by a square. Okay, the total energy is half of k multiplied by a square, and k can be written as m omega square. So you get total energy is equal to half of m omega square a square. Okay, this thing is clear. This total energy can be written as what? Half of k into a square that we have seen, and out of that the potential energy is half of k into x square, kinetic energy is half of k multiplied by a square minus x square. So now suppose I want to plot it, the potential energy, kinetic energy, okay, and the total energy against the position of the object. Okay, so this is x equal to 0, this is x equal to plus a, and this is x equal to minus a, right? And this is my 0, right? This is my 0. I will plot energy on the vertical axis, okay, energy on the vertical axis. So see, the potential energy will look like this, because it is half of k into x square. This is just a parabola, okay? It looks like this, right? Then if you plot the kinetic energy, so this is potential energy, okay? If you plot the kinetic energy, it will look like this. The curve looks like this. And if you plot total energy is constant, so the curve looks like this. It is just addition of potential and kinetic energies. So you can see at the midpoint, at the equilibrium position, what will happen to the kinetic energy? What will happen to the potential energy? So x is equal to 0, potential energy is 0. What is kinetic energy? Half of k, a square minus x square. So put x equal to 0, okay, put x equal to 0, and what do you get? The kinetic energy would be half of k multiplied by a square. That means kinetic energy is maximum at what? X equal to 0. So it's maximum here, right? And potential energy is maximum at x equal to a. That's very clear, because it is half of k multiplied by x square. Put x equal to a, then you get half of k multiplied by a square. So that is potential energy at the extreme positions, right? Potential energy is maximum at extreme positions, minimum at 0. So the graph will look like this. Kinetic energy is maximum at mean position, and at extreme position the object stops, and therefore it will look like this, okay? So next I want to plot these graphs against time, okay? So if you plot position versus time, the graph looks like this, right? We have seen this. So suppose the object starts from the mean position, then position versus time graph looks like this, right? So now what is potential energy? Potential energy is half of k multiplied by x square. So if you plot potential energy versus time, what will happen? So see, if you go from here to here, okay, so position is changing from 0 to a. So the potential energy will also change from 0 to what? Half of k into a square, okay? So potential energy will start at t equal to 0, position is x equal to 0. So potential energy half of k into x square, x is 0, so potential energy is 0. Then it goes like this, because x changes this way, okay, it is oscillatory motion. So x increases at t equal to t by 4. What happens to x? X becomes maximum, x becomes a. So what happens to the potential energy? It becomes half of k multiplied by x square, right? And x is a, so it is half of k into a square. Then it decreases, okay? So x, again object comes back to the mean position, right, at t equals to t by 2. Then what happens to the potential energy? Potential energy also decreases like this. Then object goes on the other side, okay, object goes to positive extreme position, then it comes back, then it goes to other side, okay? But when it goes to other side, the displacement would be negative, but potential energy is half of k into x square only, half of k into x square only. Even if x is negative, the potential energy would be positive only, right? So this graph, it will follow the same pattern, okay, like this. So it will, see, position is changing, object is going away from the mean position, and it goes to negative extreme position. So at t equal to small t equal to 3t by 4, it goes to negative extreme, and then potential energy again becomes maximum, right? So the graph of potential energy will look like this. And now if you see this one, the motion of object is a periodic motion. Then if you see the graph of potential energy is also periodic, but what is its period? Its period is equal to t by 2. Okay, can you see that it repeats after every t by 2. Similarly, the graph of kinetic energy will also repeat after every t by 2. Okay, so its frequency is twice. Its frequency is twice. Okay, is this thing clear? Yes, no? Period of the potential energy and kinetic energy is what? It is t by 2 because it repeats after every t by 2. But its frequency would be twice as that of the frequency of this object. Is it clear, everyone? Alright, good. So now let us see some problems based upon this. So a body is executing simple harmonic motion with frequency n. The frequency of its potential energy is, so we just saw this is from NEET 2021. So what is the frequency? Tell me. A direct question. The frequency of potential energy is, what's the problem? It is 2n, right? Yeah, it's option C. Okay, we just saw this. The time period is what? Time period is half because this potential energy will repeat after every t by 2. Okay, so time period becomes half, means frequency becomes what? Twice. Okay, so if n is the frequency of this one object's oscillatory motion, then the frequency of the potential energy as well as kinetic energy would be equal to 2 times n. Okay, twice of n. It's very simple. Okay, and we need to remember this. Alright, let's see next one. The particle executing simple harmonic motion has a kinetic energy k naught cos square omega t. The maximum values of potential energy and the total energy are respectively. Okay, the particle executing simple harmonic motion has a kinetic energy of k naught cos square of omega t. Then the maximum values of potential energy and total energy are respectively. Tell me. K naught and k naught, right? Okay, so k is equal to k naught cos square of omega t. What is its maximum value? So this cos square omega t can be at max equal to 1. Okay, so k max is equal to k naught. That is very clear, right? But then they say the maximum value of potential energy and total energy. So we know this, that at mean position the kinetic energy would be maximum, and how much would be the kinetic energy? So k max is equal to half of k into a square, and total energy is equal to half of k into a square, and maximum of potential energy is also the same, it is half of k into a square only, right? So maximum potential energy and maximum kinetic energy and total energy is all same, because what happens at the mean position? At mean position potential energy is 0, total energy is kinetic. At extreme positions the kinetic energy is 0 and total energy is potential energy only, right? So that's why this is the answer. Okay, so that's very simple. Right? Okay, good. Let's see next one. The potential energy of a simple harmonic oscillator when particle is halfway to its end point is. Okay, tell me. So if E is equal to, okay, E is the total energy, then E has to be equal to half of k into a square, and the potential energy is half of k multiplied by x square, which is half of k multiplied by the particle is halfway to its end point, means half of k multiplied by a by 2 square. So this thing would be a square by 4, right? This is a square by 4, and therefore what do you get? This would be 1/4 of half of k times a square. So that is 1/4 of e. That's very simple, right? It's 1/4 of e. So it's option C. Okay, this is clear. All right, good. Let us see next one. A particle of mass m oscillates with simple harmonic motion between points x1 and x2. The equilibrium position being O or 0, its potential energy is plotted. It will be as given below in the graph. So this is very simple, right? What's the answer? It's option A. Good. All right, let's see next one. The displacement between maximum potential energy position and maximum kinetic energy position for a particle executing simple harmonic motion is, tell me. Where is the potential energy maximum, where is the kinetic energy maximum, and displacement, or you can say, yeah, displacement between those points. So option B, option C, right? That's correct. Okay, that is very simple, because see, we have, this is potential energy, this is kinetic energy. Okay, kinetic energy is maximum at x equal to 0 and potential energy is maximum either at x equal to minus a or at x equal to plus a. So the displacement between them is either minus a or plus a, right? Displacement between the positions where the kinetic energy is maximum and potential energy is maximum is either minus a or plus a. Okay, so that's very simple. All right, let's see next one. The total energy of particle performing SHM depends on, tell me. The total energy of a particle performing SHM depends on. Total energy is, okay, just write down the formula of total energy. So energy is equal to what? Half of k multiplied by a square, right? So there a is amplitude only. Now I take separate, I mean uppercase a for amplitude and lowercase a for acceleration to avoid any confusion, right? But this a is amplitude. Okay, so this one depends on k and a. It doesn't depend on x or anything else. No, it is only k and a. Right, total energy only depends on k and a. Why not m? It's because, see, k is equal to m times omega square. Okay, and now if mass changes, omega will get adjusted in a way that the product of m times omega square is equal to k, and then total energy would be equal to half of k multiplied by a square. So see, it's option B only. Okay, this is clear, everyone. Or let me explain it in different way. Okay, so now there might be a question like this: why k is, why should you give priority to k compared to that of m and omega? Okay, or why k is more fundamental when energy is concerned? compared to that of m and omega. The reason behind that is, when suppose a spring is stretched, what happens? It gains some potential energy. How much of potential energy does it gain? It is half of k into a square, let's say, right? The spring is stretched to x equal to a. Okay, spring is stretched. Spring is stretched to x equal to a, and then it is released. So now, where does the kinetic energy come from? It comes from, see, the potential energy will decrease and that energy will get converted to kinetic energy only. Okay, so where does the potential energy come from? It comes from the work done against the spring. Okay, and that is just half of k into a square, right? So it does not depend on mass. Okay, this is clear. Okay, good. All right, let's see next question. A linear harmonic oscillator of force constant 2 multiplied by 10 raised to 6 Newton per meter and displacement 0.01 meter has a total mechanical energy of 160 joules. Its potential energy is 160 joule, potential energy 0. Okay, what is the potential energy? This is the question. Okay, so U is equal to what? Half of k multiplied by x square. Okay, put the values. So k is this thing, half of 2 multiplied by 10 raised to 6, and x is 0.01, so that is 10 raised to minus 2. Square of that would be 10 raised to minus 4. Okay, so this thing gets cancelled, 2 gets cancelled, 10 raised to 6 minus 4 is 10 raised to 2. So that's very simple. Potential energy is just 100 joules. Okay, it is option C, right? Everyone? Okay, good. Let's see next one. A loaded vertical spring executes SHM with a time period of 4 seconds. The difference between the kinetic energy and potential energy of the system varies with period of. We have seen this. Period of SHM, T is equal to 4 seconds. Okay. Then period of, tell me. Yeah, it's option A. Okay. Period of potential energy and kinetic energy is just T by 2. Okay, so that is 2 seconds, right? So very simple. Okay, let's move on to the next question. In a simple harmonic motion, when the displacement is 1/2 the amplitude, what fraction of total energy is kinetic? Okay, so what fraction of total energy is kinetic? So that's very simple again. So see, you want kinetic energy divided by total energy. What is kinetic energy? So it is half of k multiplied by a square minus x square. Total energy is half k multiplied by a square only. So that half k will get cancelled out. Okay, so you have a square minus x square divided by a square. So there is nothing in it. X is equal to a by 2. Substitute that here. So it will be a square by 4. A square minus a square by 4 would be 3 by 4 a square, and then that a square gets cancelled. So the answer is 3 by 4. Right? So the answer is 3 by 4. The next is addition of 2 SHM. Right? Addition of 2 SHM. So now suppose the first SHM is A1 sine of omega t plus phi 1. Second one is A2 sine of omega t plus phi 2. So what is this thing, you might say? So suppose you have one spring, okay, and you have another spring, and then you connect a mass to those combination of two springs. So you have two SHMs means you have two springs suppose, and they are connected to each other, okay, right, and they are displacing some particle from the mean position. X1 is displacement caused by the first spring, you can say X2 is the displacement caused by the second one, okay, and that is, first one is A1 sine of omega t plus phi 1, second one is A2 sine of omega t plus phi 2. So now how will you add these two? Okay, so now addition of these two will give us the resultant displacement, okay, and then there would be a lengthy derivation. So what we need to remember here is just suppose there is a phase difference of phi 1 minus phi 2. So phase of first one is phi 1, phase of second one is phi 2, okay, we don't care which one is first and which one is second, the phase difference between them is phi 1 minus phi 2. So you can take actually the absolute value of this one, phase difference is phi 1 minus phi 2, absolute value of phi 1 minus phi 2, okay, and then what will happen when you add it up, the resultant of 2 SHM will also be an SHM, okay, and that X is suppose the total displacement, it can be written as R sine of omega t plus phi, plus delta. What is the delta and what is R? That we need to remember, at least R we need to remember. So delta would be tan inverse of A1 sine phi 1 plus A2 sine phi 2 divided by A1 cos phi 1 plus A2 cos phi 2, okay, not difficult, right? Delta is tan inverse of A1 sine phi 1 plus A2 sine phi 2 divided by A1 cos phi 1 plus A2 cos phi 2, and R is just square root of A1 square plus A2 square plus 2A1 A2 cos of phi 1 minus phi 2. So if phase difference is phi, then you can just say it is square root of A1 square plus A2 square plus 2 times A1 A2 cos of phi. Are the formulas clear? Yes, no? So then let's see the next topic, time period of a pendulum. So suppose you have this pendulum, right? So this is a mass connected to a string, and the string, other end of the string is connected to a rigid support, and then you stretch this mass to this position suppose, and you release it. So here suppose this pendulum is stretched by an angle of theta, okay, pendulum is stretched by an angle of theta. Then now what will happen? So see here, there is a force acting on this pendulum, that is mg. Mg is the force acting on it, and it is directed downwards, so let's say minus mg, okay. So then if you resolve it along two components, so you get one component as mg sine theta, another component is mg cos theta with the negative sign, right? So component in direction of the string, it is mg cos theta, component along the string, component perpendicular to that is mg sine theta. So now what will this component along the string do? There is another force along the string, that is tension in the string, okay. So tension in the string is directed towards the rigid support, okay, like this. So this component of the gravitational force or its weight, right, it will balance the tension, okay, it will balance the tension. And what will the other component do? It will try to restore it back, okay. So the mass is pulled this way, the other component, that is mg sine theta, it will try to restore it back. How does it try to restore it back? It exerts some torque, okay. So now we know what is torque. So see, torque due to tension in the string, what would be that? We want torque about point O. So we know torque is equal to what? R bar cross F bar. Torque due to any force is R bar cross F bar, okay. So then suppose tension acts on this mass, okay, towards the mean position, so it acts in this direction. So what is R? R is equal to length of the string, okay, R is equal to length of the string. So the torque would be equal to what? Rf sine theta, right, because torque is equal to R bar cross F bar. If you take its magnitude, it is Rf sine theta, right? Magnitude of this one is Rf sine theta. So for tension, it would be, see, R is equal to L, okay, length of the string, tension is T, and then R is directed like this, tension is directed like this. So the angle between them is 180 degrees, and therefore it is L times T into sine of 180. So sine 180 is 0, and therefore torque is equal to 0. Or we can just say that tension acts along the length of string, and therefore torque due to that is 0. Okay. And then torque due to the gravitational force, or torque due to weight, you can say. So again, one is acting along the length, right? One component of gravitational force is acting along the length, so torque due to that one is also 0. So what is left is only this component, okay, minus mg sine theta, and torque due to that one would be what? L times of this force, which is minus mg sine theta, and angle between them is what? 90 degrees. So therefore it is L multiplied by minus mg sine theta into sine of 90. Okay, R into F multiplied by sine of theta, right? And then sine 90 is 1, so therefore torque is equal to what? Minus of mg into L multiplied by sine of theta. Okay, this thing is clear, everyone? All right, good. So then total torque is equal to what? Minus mg L into sine theta, and we know this for very small angles, sine theta is nearly equal to theta. Okay, sine theta and theta, they are almost equal if the angle is small. So the total torque can be just written as minus mgl, it was sine theta, and if angle is small, we can write it as theta only. And then we know the torque is equal to I alpha, okay, where I is moment of inertia, alpha is what? Alpha is angular acceleration. So you substitute I alpha over here, so you get I alpha is equal to minus mgl multiplied by theta, and then alpha. Okay, so what is moment of inertia? So moment of inertia of this mass about this point, okay, axis of rotation passing through this point, would be what? This mass m multiplied by length square, okay, or distance square, you can say, not length square, distance square, ml square. So its moment of inertia is ml square, okay. So I is equal to ml square, then you have ml square multiplied by alpha is equal to minus mgl into theta, and then now you cancel out something, so mass and mass gets cancelled out, this length gets cancelled out with this one, and L goes on other side, so you get alpha is equal to minus g by L into multiplied by theta. Alpha is equal to minus g by L times theta, and then you know that alpha is equal to, what is alpha? It is angular acceleration. So just like linear acceleration is d2x by dt square, angular acceleration can be written as what? d2 theta by dt square. Okay, it can be written as d2 theta by dt square. So then you have d2 theta by dt square is equal to minus g by L times of theta, right? And this is differential equation of angular SHM of pendulum. Okay, what is this? This is the differential equation of the angular SHM of pendulum. Okay, is this one clear? Right. So now we can compare this with differential equation of linear SHM. Okay, we can compare this with differential equation of linear SHM. So comparing, we get that omega square here must be equal to g by L. Okay, so just like in case of linear SHM, we had d2x by dt square is equal to minus of k by m into x, and k by m we substitute it as omega square. So now the two equations are similar, that means solution for this would be similar to that of solution of this equation. So we must substitute g by L as omega square. And what would be omega? So omega is angular frequency. Okay, so we substitute omega square equals to g by L in that equation. So we get d2 theta by dt square is equal to minus of omega square theta. Okay, so this is another form of the differential equation of angular SHM. Okay, and then therefore you get omega is equal to what? Take square root of this. So we get omega equals to square root of g by L, and omega can be written as 2 pi f. Okay, omega is angular frequency, it can be written as 2 pi f. So we get 2 pi f is equal to square root of g by L, right? And therefore frequency would be equal to, okay, frequency would be equal to 1 upon 2 pi root of g by L. Okay, and then time period of pendulum, would be just reciprocal of the frequency. So you get t equals to 2 pi square root of L by g. Okay, time period is equal to 2 pi square root of L by g. Okay, so is this thing clear, everyone? All right. So Yamini says why g by L has to be omega square, right? So see, if you compare this equation with this one, differential equation of linear SHM. So if you remember, we had solved this equation by substituting k by m equals to omega square. Okay, k by m equals to omega square, right? Okay, so that's why here we'll substitute g by L as omega square. Let us try some problems based upon pendulum, and what else did we see? Okay, combination of SHM. So let us solve some problems based on this. Okay, so two pendulums of length 121 centimeter and 100 centimeter start vibrating in phase. Okay, can you see this? This is little bit faint. All right. So two pendulums of length 121 centimeter and 100 centimeter start vibrating in phase. So at the beginning their phase is equal. In phase means their phase is equal. At some instant the two are at their mean position in same phase. The minimum number of vibrations of the shorter pendulum after which the two are again in the same phase, in phase at the mean position is. Okay, two pendulums of length 121 centimeter and 100 centimeters start vibrating in phase. At some instant the two are at their mean position in same phase. The minimum number of vibrations of shorter pendulum after which the two are again in phase at the mean position is. Okay, so at some instant of time they are in phase at the mean position, suppose, and both oscillate. So length of these pendulums are different, that means they will oscillate with different frequencies. Okay, and then you want after how many oscillations the minimum number of vibrations of the shorter pendulum after which the two are again in phase. Okay, this is the question. All right, tell me. So let's say that Ns is number of oscillations of shorter pendulum and Nt is number of oscillations, Nl is number of oscillations of longer pendulum. Okay, this is number of oscillations of shorter pendulum and this is number of oscillations of the longer one. Okay, So then what can we say here? After some time, so at the beginning, let's say t is equal to 0. After some time, what happens? They again come in phase. Okay, they again come in phase. So the total time that has passed can be written either this way, that how many times the shorter pendulum has oscillated in that time. Ns is the number of times it has oscillated multiplied by the time period of shorter pendulum, right? Or it can be written as how many times the longer pendulum has oscillated multiplied by the time period of longer pendulum. Okay, so that's simple. The time that has passed is equal for both of them, right? So therefore you can say ns times time period of shorter one is equal to nl times the time period of longer one. Okay, and then you know time period is just 2 pi multiplied by square root of L by G. So then G and pi is constant, so time period is directly proportional to root of L. So therefore here you can just substitute Ns times root of Ls, or before that let's substitute Ns by Nl would be equal to what? TL by Ts, and that is T is directly proportional to root of L. So let's substitute length of the longer one, so let's put L suffix L, length of the shorter one Ls. Okay, so what is length of longer one? It's 121. Length of shorter one is 100. Okay, so you get Ns by Nl is equal to square root of 121 divided by root of 100. Okay, that's 10, right? So this is 11 by 10. So ratio of number of oscillations of these two when they again come in phase is 11 by 10. Okay, and it is not further divisible. That means the shorter one must oscillate 11 times, longer one must oscillate 10 times, right? So that they again come in phase. Is this one clear? So answer is option D. Shorter one oscillates 11 times, right? So this one is from NEET 2022. Okay, all right, let's see next one. The oscillation of a body on smooth horizontal surface is represented by x is equal to a cos omega t, where x is displacement at time t, omega is frequency of oscillation. Which one of the following graphs shows correctly the variation of a with t? A is acceleration at time t, t is the time period. Tell me which one represents the variation of a with t. Yeah, it's option C. That's very simple. Okay, because we know acceleration is just minus of omega square x. So x is a cos omega t, that means its graph will look like this, right? X is what? A cos omega t, that means at t equal to 0, x will be what? X will be equal to plus a. Okay, we know when object starts from extreme position, then its equation for the position is what? X is equal to a cos omega t. Okay, so at t equal to 0, x will be equal to a, the extreme position. Okay, so then now acceleration is minus of omega square x, that means the sign between a and x is the sign is negative here. Okay, they are opposite to each other. So if x is above the time axis, then a has to be below the time axis. Okay, so at the beginning, if x is above the time axis, a has to be below the time axis. This thing is clear, everyone? A very simple question, right? Okay, let's see next one. Which one of the following equations of motion represents simple harmonic motion? Acceleration equals to minus k times x plus a. Acceleration is k times x plus a. Acceleration is kx. Acceleration is minus k naught times x plus kx square. Which one is correct? See, we have force directly proportional to what? Displacement, and force is equal to minus k times x, right? Now, force can be written as mass times acceleration. So, you have mass times acceleration is equal to minus k times x. Now, if you take m equal to 1, then equation for acceleration would also become minus k times x, right? So, for m equal to 1, okay. Now, they are not saying whether this k is spring constant, this k is something, okay. So, here what you can do is acceleration, generally it is k by m, and that k by m, suppose they are writing it as k, okay, k by m is written as k, right? Okay, so acceleration, either you consider m is equal to 1, so you get acceleration is minus kx, or you can say k by m in our equation where acceleration is minus k by m times x, that is written as k here, okay. So now see, acceleration and x, they will always have opposite phases. Opposite means phase difference is pi, okay. So there would be always a negative sign, okay. But then see, in option B and option C, the sign is positive. So this one and this one cannot be correct, right? And out of this one and this one, which one is correct? So here see, it is minus k naught times x plus there is an extra term, okay, which is k1 multiplied by x square. So this is like an energy term, okay. This is not like an acceleration or force term, this is like an energy term. So acceleration doesn't vary as x square, right? So see, this one is the only option, okay. And then now here in option A, okay, I have little problem with the question setters. They use same A for acceleration as well as some position, okay, or extreme position, etc. Okay, so no problem. So acceleration is equal to minus of k times x plus a, they have written. We can consider that x plus a is equal to x prime. So we get this equation, a is equal to minus k x prime, okay. So in place of x, here x prime will perform oscillatory motion, okay. So here x performs oscillatory motion, means equation for x can be written as a sin omega t or a cos omega t. Suppose it starts from mean, so it can be written as a sin of omega t. Here you can write that x prime is equal to a sin of omega t, okay. And what is x prime? So x prime is equal to, it is x plus a, you can move that a on other side, so therefore it is a plus a sin of omega t, okay. That was plus a, so here it will become minus a, okay. So at t equal to 0, suppose it starts from mean position, therefore you will get this equation, right? What is the mean of this? So mean of this one is what? X equal to 0 only. What is mean of x prime? So mean of x prime is minus a, okay. Mean of x prime is just minus a. This thing is clear. X prime is equal to x plus a, and that is a sin of omega t. Move a on other side, so you get x is equal to minus a plus a sin of omega t, okay. So mean of x is equal to 0, but mean of x prime is not x equal to 0, it is x equal to minus a, right? Because if t is equal to 0, then you will get x equal to minus a. Is this one clear? Yes, no? Okay, so this is oscillatory motion, just mean is changed, mean position is changed, right? The answer is A. Okay, Indusha, is it clear? Selva Kumar, Indusha, Nikita.
Yes, sir.
Okay, good. All right. So this is simple question. Let's see next one. The radius of circle, the period of revolution, initial position and sense of revolution are indicated in figure. Okay, in this figure they are indicated. Y projection of the radius vector of rotating particle P is. Okay, so your particle is at this position. Okay, if I zoom it, see at t equal to 0, the particle is at this position P and it moves like this. Okay, if it moves like this, now if you consider its y projection, they are asking about y projection, right? So y projection of the radius vector of rotating particle P is. So that's simple. So let's draw a position vector. Okay, let's draw a position vector. Suppose this is position vector at some time. Okay, then it is rotating in this way, means starting position is this one. Okay, this is the starting position and after some time t it has moved from here to here. Okay, so it covers some angle theta. What would be theta? We know omega is equal to theta divided by t, right? So theta would be equal to omega t, and then you can resolve this radius vector along two components, but we want only y component. We want y projection means y component, right? So y just equal to what? R cos theta here. Okay, y would be equal to r cos theta, that is it's equal to r cos of omega t. Okay, and then put the values. What is omega? So t is given, right? So put omega and the radius is equal to 3. So this is equal to 3 cos of 2 pi by t. Omega is 2 pi by t, 2 pi by t into t, and then what is t? T is equal to 4, right? T is equal to 4. So put t equal to 4 there. 2 by 4 means 1 by 2. So it will be 3 cos of pi by 2 into t. So that's the answer. Okay, so 3 cos of pi by 2 times t. So what's the answer? It's 3 cos of pi t by 2, and where y is in meter. Yeah, so it's option A. Right, this is from NEET 2019. Let's see this one. A body of mass m is attached to lower end of a spring whose upper end is fixed. The spring has negligible mass. When mass m is slightly pulled down and released, it oscillates with time period of 3 seconds. When mass m is increased by 1 kg, the time period of oscillation becomes 5 seconds. The value of m in kg is. Okay, this is just based upon spring mass system, right? So when mass is equal to m, then the time period is 3 seconds, and when mass is increased by 1 kg, the time period becomes 5 seconds. Okay, so you know the formula for time period. So t is equal to what? 2 pi square root of m by k, right? So time period is directly proportional to root of m. Okay, so t1 by t2 you can say is equal to square root of m divided by, now mass is increased by 1, so it would be m plus 1, and we want to find out m. That's very simple. So let's substitute t1 and t2. So that is equal to, so then we get square root of m divided by m plus 1 is equal to what? 3 by 5. Okay, so square it, so we get 9 by 25 is equal to m divided by m plus 1. Then do cross multiplication. So you have 25m is equal to 9m plus 9, right? 9m plus 9. So that 9m will go on other side. So it is 25 minus 9 means 16m is equal to 9. 16m is equal to 9 and therefore m is equal to 9 by 16. That's very simple. Okay, so m is equal to 9 by 16. This is clear? Yes, no? Alright, let's see next one. The displacement of a particle executing simple harmonic motion is given by y is equal to a naught plus a sin omega t plus b cos omega t. Then the amplitude of this oscillation is given by, tell me. So again this is similar to the last question. So here y is equal to a naught plus a sin omega t plus b times cos omega t, which can be written as what? Sin of omega t plus pi by 2, and this is from NEET 2019. So again a naught is what? It's just a constant. Okay, so it is combination of these two SHMs. This is first one, this is second one. Okay, and then what is your formula? So r is just equal to, you want resultant amplitude, so r is just equal to square root of a square plus b square plus 2 times amplitude of first one multiplied by amplitude of second one multiplied by cos of the angle between two. Okay, cos of angle between two means cos of the phase difference between two. So what is phase of this one? It's 0. What is phase of this one? It's pi by 2. So it is cos of pi by 2. Right, and cos pi by 2 is 0. So therefore, what is r? It's just square root of a square plus b square. It is option C. Right? Yes, no? Is there a confusion in this? Okay, if there is some confusion, what you can do is you can just move a naught on other side and you can say y prime is equal to y minus a naught. Okay, and that will be SHM. If that is an SHM, if y prime which is equal to y minus a naught is SHM, then y is also SHM, because see, y prime will oscillate, okay, with frequency omega, means y will also oscillate with frequency omega, because what's the difference between them? Difference between them is just a naught. So these are 2 points. One point is oscillating, okay, one position is changing as y prime is equal to a sine of or something r sine of omega t, suppose. So second position is also, it should also change, okay, accordingly, right? We had seen this thing also yesterday. You can think of it as, this is suppose your spring mass system. Okay, so the distance between these 2 points is a naught, or let's take mean position. The distance between this and this point, okay, this much distance is suppose a naught. So if this is y prime, this point is y. Okay, so this block oscillates, means y prime will change. Okay, y prime will change with what equation? Y prime is equal to r multiplied by sine of omega t. Okay, where r would be equal to square root of a square plus b square. So if y prime changes, right, y prime oscillates, y will also oscillate. You can assign y to, let's say, this edge, one end point or one edge of this block. Right, this thing is clear, everyone? And the separation between 2 points is a naught. A naught is just a constant. Okay, if you add constant to SHM, it is still SHM. Okay, if you add, suppose this SHM and this SHM, we have seen if frequencies are equal, then combination of 2 SHM is also SHM, right? So this is SHM having amplitude equal to this much. Okay, so then you are adding this constant to SHM, so that is still SHM only with same amplitude. Okay, just there will be addition of a naught. Okay, so this gives some position, suppose there will be just addition of a naught in that position every time. that will not change the amplitude. This thing is clear, everyone? Right, good. All right. So answer is option C. Okay, let's see next one. The period of oscillation of mass m suspended from a spring of negligible mass is t. If along with it another mass m is also suspended, the period of oscillation will now be. Okay, tell me. So first one, first mass was m and time period was t, and then another mass m is suspended. This is very simple, right? So t1 by t2, or let's say t2 by t1 would be just equal to what? Square root of m2 by m1. Okay, because t is directly proportional to square root of m. T is equal to what? It is 2 pi square root of m by k. This is the formula. So t is directly proportional to root of m. Okay, and m2 is 2m, m1 is m, so that mm gets cancelled out. What remains is t2 by t1 is root 2, means t2 is equal to root 2 times of t1, right, or root 2 times of t. So it is option D. Right? Okay, good. So then let's see this one. A simple pendulum performs simple harmonic motion about x equal to 0 with an amplitude a and time period t. The speed of pendulum at x equal to a by 2 will be. Okay, so for speed you will just use the formula that you saw for simple harmonic motion. So what's that? V just equal to what? V is equal to omega square root of a square minus, again they use this small a, okay, lowercase a. Okay, so a square minus x square. Okay, and in all of the options t is there, so that means you need to substitute omega is equal to 2 pi by t, and then you have a square minus x is equal to a by 2, you substitute that, so it will be a by 2 square. A square minus a by 2 square is a square by 4. Out of that a square you can take common and take root of that, so it will be a. So it is 2 pi by t into a multiplied by, then it will be 1 minus 1 by 4, so it's 3 by 4. So square root of 3 by 4 is root 3 divided by 2, right? And 2 will get cancelled out, so that's the answer. Root 3 times pi a divided by t, so that is the answer. Root 3 times pi a by t, so it is option C. Okay, all right, this is clear, everyone.